Alright, hey guys, this is your teacher, Mrs. Tran-Bloom again. So just to start off our video today, I'm gonna give you a joke, right? Why not? Let's start out the video with a little bit of laughter. 4-year-old that is. So where do sheep go on vacation? So where do sheep go on vacation? Pretty simple. We love vacation. So where do sheep go on vacation? They go to the Bahamas. Alright, that is your toddler joke for today. This is example 3. Now, keep in mind that I just want to remind you over and over again, you have to understand your notes, not just copying for the purpose of copying. So if you don't understand it, please listen to it again. Okay. Given the function, or consider the function, f of x, so right away we know it's a function without even stating it's a function because of this notation right here. X divided by x plus 1. See, I'm going to use a pencil because I make a lot of mistakes. Is the point 1 comma 1/2 on the graph? So notice how this is telling you that this is a point, because without stating the question or telling us what this is, we might be confused that this can also be an interval. So it says this is a point. Is the point 1 comma 1/2 on the graph of f? So what we need to do to test is, remember, this is an x coordinate, this is your y coordinate, okay? And y is the same as f of x, as you remember. If I know what x is, okay, and I know what y is, I can just plug it in to see if they are equal. If they are equal, then the point is on the graph. So here we go. X, see that right there? That is 1 divided by x. See that right there? I'm just going to put it in there. 1. This is a normal one that doesn't have an x, so just bring it over. Question mark. Okay, what is it equal to? Well, let's work out the denominator first. 1 plus 1 is 2. So that equals to 1/2. Whoa, that is the same as that one. So therefore, yes, okay, 1 comma 1/2 is on the graph. And box up, because that's our final answer. Part B. If x equals 2, what is f of x? Okay, and then we're going to answer the second part later. So this is your input. I'm trying to look for the output. You are correct. So let's find what f of 2 is. F of 2 equals, every time I see an x, I'm going to put in 2. So 2 over 2, and then I'm going to bring the 1 over, plus 1. This will give me a 2 over 3. So f of x is 2 over 3 when x is 2. The second half of this says, what point is on the graph of f? Well, the point is simply stating an x coordinate and a y coordinate. Well, x is 2. I found my y, which is also known as f of x, and I found it, and the value is 2/3. Box that up, because it's also the answer to one of the questions. Part C. If f of x equals to 2, what is x? Okay, so let's read this again. If f of x equals to 2, what is x? So this value right here, is that an x value? I hope you said no, because this is actually a y value. And I'm searching for x. It even said so. It says, what is x? Okay, because it's a y value, I'm going to put it in here, f of x. Okay, so f of x is 2. Substitute f of x for 2 equals 2. Bring this over, x divided by x plus 1. Because I am looking for x value, so I'm going to try to solve for x. What I'm going to do here is, you have multiple options, but the option number 1 I'm going to use is I'm going to make that into a fraction and cross multiply. Okay. Then I have cross multiply 2 times the quantity of x plus 1. So 2 times the quantity of x plus 1 equal to x times 1 is simply x. And again, my goal is to find x, so I'm going to solve for x. Distribute. That gives me 2x plus 2 equals x. Get x to one side, so I'm going to subtract 2x on both sides here. I'm going to end up with 2 equals to negative x. Okay. Multiply both sides by negative 1. So x is going to come out to be a negative 2. Okay. So x is negative 2. For me to get a y value of 2. And it says what point is on the graph of f. Now, when you're asking for a point, you need to write x comma y. Okay. So this is my x value. So I'm going to write negative 2 comma, and my y value is 2. So I'm going to box that up. There you go. You got 2 answers because you got 2 questions. Okay. What is the domain of f? Okay. We have been doing a lot of domain questions. So hopefully by now you're super comfortable with domain questions. The domain is always going to be all reals unless you have 2 things going on. Okay. Thing number 1. Unless you have a radical, then you need to find the values of that. Or unless you have a denominator. In this case, you have a denominator. So I'm going to assign values that I need to exclude. So what is the domain of f? I'm going to take your denominator. I'm going to set it equal to 0 so I can exclude that. Subtract 1 from both sides. X happened to be negative 1. This value, negative 1, makes my denominator 0, in which I will need to exclude. So domain, okay, x can never ever be negative 1. It's all real numbers, not including negative 1. But because we are going to go away from Algebra 1 notations, we are going to write it as interval notation as well. Negative infinity all the way to negative 1, union that with negative 1 to positive infinity. And that is our interval, which I'm going to write the word or, notation. E, list the x-intercepts, if any. Now, x-intercept is when y is 0, okay? So I'm going to take my equation, which is now hidden, this equation right here, put 0 in. 0 equals x over x plus 1. Now, again, I'm just going to solve it the same way I solved up here. I'm going to make 0 into a fraction. But what happened when I cross multiply? 0 times anything, it's just going to be simply 0, right? And then over here, I can cross multiply that. X times 1 is x. So your x-intercept, okay, when y is 0, x-intercept is also at 0. Looks like a little face, 2 eyes and a nose. Okay. F, lists the y-intercepts, if any. Okay, y-intercept is when x equals to 0. Okay. So I'm going to put 0 in there, 0 in there to see what happens. Y equals 0 on the top, 0 plus 1. Well, 0 divided by 1. That's what I end up with, right? 0 plus 1 is 1. So 0 divided by 1. No, you may not leave it like that. 0 by anything is just simply 0. So your y-intercept happen to also be at 0, 0. So both of these, x and y-intercept, they are crossing over. It's the same point. So the point is crossing over your origin. And that is how we find information about an equation. Now, if you understood nothing, please listen to it again, okay, before you go on and do the check for understanding all by yourself. See this check for understanding right here? Look at the questions. I'm giving you a function. I'm asking you pretty much exactly the same things here. So if you didn't understand it, please listen to it again before you start your check for you. So I'm going to turn sideways on your own. And again, listen to example 3 again before you complete your check for understanding, if you didn't understand it the first time around. All right, hit pause, complete your check for understanding. And so that way, when you're done, then you can continue with example 4. Okay, there you go. Example 4. Okay. You might need to use your calculator for this. Okay, so I'm gonna go find my calculator. I have an old school TI 84. You can use an 83. Anything you want, as long as you know how to use it. Example 4. We're dealing with word problems, so let's carefully read it. The average cost, so now it's denoted with the C and a symbol on the top, of manufacturing an X number of computers per day is given by a nice function. Okay, so X represents number of computers per day. Manufacturing, manufacturing. Okay, computer that we're making per day. And C of X, I'm sorry, not C is the average cost. So we have to understand what the variables stand for. C of X equals 0.56x squared, take away 34.39x plus 1,212.57 plus 20,000 divided by x. Okay, so determine the average cost of manufacturing first, 30 computers per day. So let's find this. The cost of 30 computers, that means your input is 30. So we're going to 0.56x squared minus 34.39 times, oops, I'm sorry, every time I see an x, I should have put in 30. So let's erase. See, I'm making a mistake. That's why I have a pencil. I hope you do too. 34.39 times 30. Then I'm going to add 12.57. Then I'm going to add 20,000 divided by 30. Okay. So I'm going to put this all in my calculator. I'm going to give you about a 30 seconds head start to calculate that on your own. And then I'll do it as well, then we can compare our answers. Okay, here we go. I'm going to try. 0.56 times 30 squared, okay, minus 34.39 times 30. Add 12.57, and then I'm going to add, I'm going to parentheses for this, okay, 20,000. 21, 2, 3, okay, I'm going to mix all my zeros there, divided by 30. And the reason I need to put parentheses around this is because in PEMDAS, you need to do multiplication and division before you can do addition. So you have to tell the calculator that. The calculator is not smart enough to do that for you, so make sure you tell it too. Okay, hit enter. All right, so because we're dealing with money, I'm going to round it to the nearest pennies here. So the average cost to produce 30 computers is $1,351.54. I hope that's what you have. Okay. Then what I'm going to ask you to do the same thing for this. Find the average cost to produce 40 computers a day. So C of 40. Okay. And then I'm going to ask you to do C of 50 as well. And I'm going to box this way, just to separate this part from that part. Okay, so go ahead and take a minute, enter in the average cost for 40, average cost of 50. And actually, you know what? Let me show you a quick way for entering average cost of 40. And if you're not following along with the calculator, you might want to hit pause and do so. So you know how we type a bunch of stuff up here? Right? And I don't want to type it again. It takes too long. So here's the magic key. See this right here? This entry? if I hit second and entry, okay, or in this case enter, here we go, second, enter, it brings back the previous thing that I put in, I enter in. So instead of entering all over again, I'm just going to go and change where I used to have my 30 and put in a 4. And Julie just changed number 3 to 4 because it's already 30 to 40. And so I have 3 spots that I need to do. Look at that. Voila! And I can hit enter. So now, average cost of producing 40 computers per day comes out to be $1,232.97. And that makes sense, right? The more you produce, okay, the cost should be cheaper. All right? Now, go ahead and do 50 for me, and then we'll compare answers. I'm going to hit second, enter. There you go. So now I'm going to go and put in 50 here. And again, you should really practice. Because on the quiz or the test, I'm not going to be able to tell you what to do, okay? All right, I'm going to hit enter. And now the average cost to produce 50 computers per day is now $1,293.07. Okay, so my question to you is this. I thought the more computers we make, the cheaper it is. Is that true? Then why is the cost of 50 more than the cost of 40? Does that make sense? Wow, that's trippy, isn't it? Okay, so that's something I want you to consider or think about as we are finishing this up. Okay, part D. So what you should be thinking about is why is the average cost increasing as I make more? I thought the more you produce, the cheaper it is. Okay, so part D. This is going to help you with a calculator. All right, graph the function. Cost is the cost in terms of x, because x represents the number of computers we produce per day. And x is between 0 and 80 computers. That means I want to produce more than 0 computer. That means at least 1 computer. And I want to produce 80 or less. Okay. So this right here, class, is your domain. Okay. And let me tell you where you're going to put your domain. Go to the window. Your domain means your x value. I want the smallest x to be 0, so it's already the 0. I want my largest x, which is the number of computers I produce per day. It's 80. Okay. These little things are important. We have to know where it's supposed to go, especially if it was on your calculator. All right, so now I have my x put in. Now I'm going to go to my y equals and clear it out. Hit clear. And I'm going to put in my equation, my original equation here, because it's a graph. And then I'm going to have to draw it out on here. Ready? 0.56. And if you have a calculator, you know how to use this. Is your x button, x. And this is your square button right there. Minus 34.39x plus 12.57 plus, remember earlier I was using parentheses. You also need to do the same here, 20,000. And then divided by, I don't have a 30 actually. In my original equation, I have an x. Okay. Ooh, wait, I hit the wrong button. I didn't want tangent, I want x. There you go. So that's my equation. My window, I've already put in my domain. So now to get a nice graph, hit zoom and go all the way down. Boop, 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 boop. Okay, I want you to see zoom fit. That means it's going to fit the data for us. Okay, and hit enter or just hit 0. Okay, you can hit 0 to do zoom fit or just hit enter. All right, look at an awesome graph. Okay, so the problem with zoom fit, and let me show you why. Go back to my window. The domain's not going to change, but check out my range. Notice how it's giving me really large range here. It's giving me like in the 20, almost 25,000s, okay? So I'm going to change it. Zoom fit gives you a good idea, but then now you have to go and change it. I want my cost to be from 0, maybe, okay, let's check out my cost here. It looks like my largest cost is about 1,293. So if I do like 3,000, let's double that. Okay. So I want to have a better looking graph than what it gave me with ZoomFit. All right, so check that out. That's a lot better. Let's go in and label our X and Y axis. You have in a word problem. Okay, and if you are the students are usually listening to video notes with muting, this is gonna come back and bite you in the ass. Label this based on the word problem. Okay, X represented manufacturing computers per day. So we're gonna write on this X number of computers, not ed, my bad, produce per day. Okay, that's your X. Now the output, which in this case is your C of X, which represents average cost. Okay. Because my domain, the input, was from 0 to 8, so I'm just going to make 8 tick marks, with each one being 10. So 10, 20, 30, 40, 50, 60, 70, 80. Okay. And if you have tick marks that are not 1 unit, then you have to label a couple of them. Then I'm going to make, remember how my window was 3,000? So I'm going to make about 500 each. 500, 1,000, 1,500, 2,000, 25, 3,000. Okay. So you have to label your tick marks if it's not worth 1 unit. Okay, so let's look at 30 computers. We calculated it. It was 1,300 and 1,300-ish, right? So right there. Okay. And then 40 computers, we calculated it was lower. 50 computers is kind of going back up. Okay, so, and if you look at the graph, it has a parabola. And it's going to go that way. And we're going to go that way according to my sketch, right? Okie dokie. Okay, so we got the graph. Are you still thinking why the more computers I'm producing is going back up? Okay. So let's talk about E and then we can answer the question. E. Create a table using table start. Okay, let's go where that is. What on earth is that? Can you guys see this table set right here? Let's move that up. Here we go. See right there? Okay, that table set. Hit second table set. And I want you to start the value at 1 computer. Right now I have something in there that says 15. Let's do 1 computer. So I want my table to start at 1 computer. And this is the table change. That means each value is an increment of 1 unit. So 1 computer in our case, okay, which I already have. And then that's it. And then go ahead and now hit second table, which is over here, second table. And I'm going to look. With 1 computer, the average cost is going to be $21,000 about, okay? We already know that we have 30, so let's go to 30 to see if it answers right. There you go. 30 computers. Our average cost is $13.51. And then it rounded to 0.5, which let's mode it. And I want it to round to 2 decimal places. Can you guys see that right there? Float 2 decimal places. So let's hit enter, and let's go back to the state table again. Oh, that didn't do it. Let's see. I don't think it does it. Look at that. Oh, on the bottom. There. There. Okay. So on the bottom, it rounded to 54, which is what we have. Then we want 40 computers. Let's go over to 40. Whoop. 40. Okay. We got 1233, which is, again, it rounded at 50. Whoop. Okay, 1293. Okay, so super close with rounding, because it looks like it's just rounding to 0.07. So if I clicked over, it looks perfectly right. All right, next. But I want to find which value of X, that means what computer should we produce per day, has the lowest cost, because I want to minimize my cost. So let's check it out. So the higher up the 50 I go, the higher of the cost. And as you can tell, this is going up. So I don't want to go higher. I want to go lower in my computer. Okay. So we said 40 computers was about 1,200. So that's definitely less. So let's look at 40. 40, 1233. 41, 1231. Okay, that's even better. 42. Oh, it's going up by $1. Can you see that right there? So based on my table, the lowest cost, the smarter way to do is produce exactly 41 computers. And based on calculator, lowest cost is, let's write the dollar amount, 1231.74 when we produce 41 computers. Okay, so this is your X right here. Because that's what it wants. All right. This concludes our 2.2. Okay, and again, don't forget to go back and do the check for understanding and listen to it again, the parts that you didn't understand. Have a wonderful day, and I will see you guys next time.